So, time for another calculus video. If you're having some issues getting your homework done, hopefully this will help you out a little bit. We're looking right now at homework number 4 and question number 5. And this is one of the word problems that's giving people a few headaches. So we're going to break it down, take it nice and slowly, and make sure that you understand exactly why we're doing what we're doing, so that if you see a problem like this in the future, you're going to be able to solve it on your own. So they tell us that a ball is thrown straight up with an initial velocity of 128 feet per second. That is a strong person throwing a ball that fast, but okay. So its height in feet after t seconds is given by the function s of t equals 128t minus 16t squared. So let's write that down and figure out what the different pieces of this function mean. So s of t equals 128t minus 16t squared. Okay, so what's the s of t? S of t is going to tell us the actual height of the ball. That's what we're interested in with this function. So this is going to say the height of the ball after t seconds. And t here is just time in seconds. So if you wanted to know what the height of the ball was after 1 second, you'd plug in a 1 for the t's and you would solve it. If you wanted to know what the height of the ball was after 3 seconds, you'd plug in a 3 for the t's and solve it. So what this function does, the only thing that it does right now for us, is tells us the height of the ball after t seconds. So let's take a look at what the question's asking us. For part A, it's asking us for the the average velocity of the ball over the following time intervals. This is exactly what we did in question number 4. So if you look at this and it's not making sense, go back and look at the video for question 4 and try to work that exercise, because I think it'll help you out with doing this. So we need to know the average velocity is what they want. Average velocity over some time intervals. Time intervals. And they give us these intervals. The intervals that they've given us are from 2 seconds to 3 seconds, from 2 seconds to 2.5 seconds, and from 2 seconds to 2.1 seconds. And like we did in question number 4, let's go ahead and label these. We'll make the first time in each interval be t1 and the second time in each interval be t2. So if you are going to set up now the formula like we did in 4 to solve these, it's going to be s of t2 minus s of t1, and that's all over t2 minus t1. So that's the function where we put in whatever the value in t2 is, minus the function where we put in whatever the value in t1 is, and then we divide that by the difference between t2 and t1. So t2 minus t1, 3 minus 2, there's going to be a 1 in the denominator when we do it for that first interval. T2 is 2.5, T1 is 2. We subtract those two. When we do this interval, there's going to be a 0.5 in the denominator. And for this one, 2.1 minus 2, there's going to be a 0.1 in the denominator when we do this. So it might actually make this a little bit easier for us to kind of plug things in and solve them. So let's go ahead and make a chart of the values that we need, so that I can just plug in whatever s of t2 is, s of t1, and we'll be able to solve these pretty quickly that way. So for t equals some number, we want to know what s of t is, so that we can just plug it into that formula. So the times that we need to look at are 2, 3, 2.5, and 2.1. And so we want to know what s of t is for each of those. So we go back to our original function, this 128t minus 16t squared, and we're just going to plug in 2 first, then we'll plug in 3, then we'll plug in 2.5, then we'll plug in 2.1. So for s of 2, That's going to be 128 times 2 minus 16 times 2 squared. And if you plug that into your calculator, the answer you are going to get will be 192. So we'll put a 192 right here. So now when we're doing T1s, all we have to do is plug in that 192 any place we see a T1. Same thing for T of 3. You're going to wind up with 128 times 3 minus 16 times 3 squared. That's S of 3. I should write that here somewhere. And if you actually solve that, plug it into your calculator, you're going to get 240. Same idea with T of 2.5. You do S of 2.5. You're just plugging in the 2.5 everywhere there was a T in the original function. And that's going to give you 128 times 2.5 minus 16 times 2.5 squared. That's going to give you 220, and I'll let you try and set up the formula for 2.1 on your own. If you did that with the numbers that we've got here on this page, you're looking at T equals 2.1 gives us S of T equals 198.24. So we actually have a little bit of a decimal thing going on here. Okay, so what do we do with these numbers? We're going to plug them into the formula that we just came up with. The S of T2, let me bring this down here a little bit, S of T2 minus S of T1 over T2 minus T1. And what that's going to look like for the first one, actually I'll just rewrite that here. S of T2 minus S of T1 over T2 minus T1. And we can take a look at the numbers that we have in our chart here, which kind of show up on the screen. Doing my best, folks. Doing my best with the resources I have. So for the interval 2, 3, the first interval that we've got, you would be looking at S of T2. So we found out what S of T2 was. T2 was 3, so we look for S of 3. That's going to be 240. Now S of T1, that's a 2, so let's go find the 2. It's 240 minus 192, and we're going to divide that by T2 minus T1. So 3 minus 2 is 1. And the answer that gives us, if you do the subtraction and the division, is going to be 48. So 48 would be the answer in the first box. Let's move on and do that for the second interval. So the second interval is the interval between 2 and 2.5. Okay, so we need S of T2 first. S of T2 is 2.5, so we need to find in our chart what we had for 2.5, and that looks like 220. Then we 220 minus our T1, which was 192, and we're going to divide all of that, not by 1 this time, because the difference between T2 and T1 is only 0.5. So 0.5, and if you do the math on that one, plug it into your calculator, you are going to find that your answer is 56. And finally, let's take a look at the last interval. That's from 2 to 2.1. We're going to plug in our T2 value. T2 is 2.1 for this one. So that's going to be 198.24 minus, well, our T1 value has been the same the whole time, minus 192. This time we're dividing by 2.1 minus 2, so that's 0.1. And if we do that division, what we come up with is 62.4. So that's what would go in that third block. So I think it might help you if you set up the table, and that way you have the numbers to pull from. You don't have to write out any kind of functions and try to do the division with the functions on the page. You just have a table and you can kind of pull the information that you need out of there. So those are our 3 rates of change that we have there, the three guesses, those three averages over those intervals. And you can see as the interval is getting smaller and smaller, the number in this case is actually getting bigger. So we kind of wonder what that means, where it's actually going. And the next natural question to ask is what they're asking us in B. And in B, the question is, what is the instantaneous rate of change at time t equals 2. Okay? So we kind of saw guesses as to where it was going, but we really want to know exactly what that rate of change is. And we've talked about that before. The rate of change, instantaneous rate of change, is the same thing as asking for the slope of the tangent line. It's the same thing as asking for f prime or s prime of something, or asking for the derivative. And what that means for us in this particular homework session is that we need to take the function that they gave us, the s of t equals 128t minus 16t squared, and we need to find the derivative. And to do that in this homework section, you're supposed to use the 4-step process. That's outlined in the file for homework question number 2 on the homework website. I'm not going to go through the entire 4-step process here, but if you do it, you should come up with s prime of t equals 128 minus 32t. That should be the answer that you come up with for finding the function, the derivative of our original function here. And so they want us to tell them what the instantaneous velocity is at time t equals 2. So we're just going to do s prime of 2. We're just going to plug in a 2 for the t. 128 minus 32 times 2, which is 128 minus 64, which is 64. And so that's what you're going to plug in for the feet per second that they're asking for in B. So to solve B, let's go over that one more time. You're going to take the original function that they gave you, you're going to find the derivative of it using the 4-step process, and then you're going to plug in the time that they asked for. In this case, they asked for time equals 2. So, and we actually see here now that if you go back to A and look at the numbers, they're actually the 48, 56, 62.4, they're all kind of getting closer and closer to the actual answer, which is 64. So that tells us that our guesses were pretty good. When we made the intervals smaller and smaller, our guesses got better, but when we looked at the actual rate of change, when we did the derivative, we got the actual answer that we were looking for. So let's take a look then at part C, which, by the way, is very similar to part B. They're asking for the instantaneous velocity at time t equals 5. So it's the same question, pretty much. Instantaneous velocity at t equals 5. So we just need that derivative that we came up in the last one. That's s prime of t equals 128 minus 32t. And this time, instead of plugging in a 2, they want to know what s prime of 5 is. So let's go ahead and plug in the 5. So it's 128 minus 32 times 5. So that's 128 minus, I'm going to do some math off on the side here. Should be able to do some, I think it's 160, but we'll check to be sure. 32 times 5, 0, 1, 15. Yep, 160. Never trust my mental math, though. I got that one right. I can't promise I will get it right ever again. So we just need to subtract these, and we actually wind up with a negative number. So you have to ask yourself really quickly, does a negative number make sense here? And it kind of does, because when we threw the ball up in the air, it was rising and it was going at a particular speed, and then it started falling at a particular speed at a certain point, because it didn't just keep going up and up and up and up. So the second part of question C is asking you whether or not the ball is rising or falling at this time. Well, at t equals 2, we had a positive number, which tells us that the ball was going up at 64 feet per second. In part C, we've got a negative number. That's telling us that the ball is coming down at 32 feet per second. So the negative number is just telling us that the ball is falling. So when they ask you in this other part of question, or other part of C, whether it's rising or falling, the negative number right here tells us that it's actually falling. And finally, part D. It's kind of interesting that they stuck this at the end, because you might think that you need to use the derivative again, since we've been using it for the last couple, but we actually don't. The question is, when will the ball hit the ground? Okay, good question. When's the ball going to hit the ground? Well, our original function that we had, this s of t equals 128t minus 16t squared, that function, if we look back at how we defined it earlier, that told us the height of the ball. And so if we want to know what time the height of the ball is 0, we just kind of need to set this side of the function up and set it equal to 0, and then we solve for t, and that's going to tell us what time the ball was at a height of 0. So let's go ahead and do that really quickly. We want to know when 0 equals 128t minus 16t squared. Okay, so then if we solve this, you go through, use your algebra, and you should come up with the answer 8 seconds. So t equals 8. If you solve this fully, you're going to get t equals 8. And that's the last answer. So just for the last one, set your function equal to 0 and solve for t. And that will do it.